In this video, I'll talk about the different ways you can connect capacitors together and how to calculate the final voltage and charge on the capacitors once they're connected. So there are two scenarios. Either you are disconnected from the battery, or you're going to be connected to the battery. So let's go disconnected from battery first. Okay, so we'll always have a before and after picture. That is before they're connected and then after they're connected. Okay, so somehow these capacitors have been charged up. We don't really care how, but they have capacitance C1 and C2. They have charge on them, and it does make a difference whether you connect them plus to plus or minus to minus. We'll go plus to plus for now. They will also have a voltage V1 and V2, which may or may not be different. Usually it's different. And they also have a charge Q1 and Q2, which again may be different from each other. The overriding equation that we were going to work with all the time is that charge is equal to capacitance times voltage. Okay, so that's the before scenario. Now we're going to take them, we're going to connect the positive lead of C1 to the positive lead of C2 so that we have a situation like this now. And what we want to know is what happens to the charge distribution and the voltages across these capacitors. So the capacitance never changes. This is still C1, this is still C2. Remember, the capacitance of a capacitor depends on its geometry. You buy it from the store, and because of its plate area and its plate separation, it has a certain capacitance, and we can't change that. But the way you charge it and hook it up, the charge and voltage can change. Okay, so this is going to have a new voltage V3 and a new voltage V4, also a new charge Q3 and a new charge Q4. And the object is to find V3, V4, Q3, Q4. Okay, so if they are not connected to a battery, then you know total charge is conserved. There's nowhere for the charge to go. So total charge is conserved. There is no source or sink for that charge. It has to just redistribute on those conserved. Okay, so we know that Q1 plus Q2 will equal Q3 plus Q4. That's a statement of charge being conserved. We also know that this configuration, even though you may think it's series, it's not. This is a parallel combination. And the reason it's parallel is because the two devices have two leads in common, this top lead and this bottom lead, which makes that a parallel combination, not a series combination. Okay, so because it's a parallel combination, we know that the voltages, once they're connected, must be the same. Okay, so that's all you need to solve anything that you're asked for. Okay, that's case one. Now case two, what happens if we leave it connected to a battery while we do this? You'll see that the situation is completely different. Okay, so we have a battery. One could be charged to that initially, it doesn't really matter, and then the second one could be out here. Okay, so this will be plus minus, we'll do it plus to plus, minus to minus as well. That's the before. And then after, we leave the battery there and we connect the second capacitor in parallel with it. Okay, so it would be C1 and C2. Remember, those don't change. Doesn't matter what we do. C1, C2 stay the same. Now the voltage of the battery, I'm going to call V bat. That doesn't change either. We're not going to wreck the battery by doing something extreme, so that stays the same. Okay, but initially this will have a voltage V1, this will have a voltage V2, this will have a charge Q1, this will have a charge Q2, this will have charge Q3, Q4, V3, and V4. Okay, now in this case, charge is not conserved because of this battery. We now have a source for charge. So if we need, after this final configuration, if we need the battery to put out more charge to either capacitor, it will do that. Or if we need the battery to take up charge, it will do that as well. So we do not write that Q1 plus Q2 equals Q3 plus Q4. But what do we write? Well, we know that because these guys are all in parallel, that the battery voltage must be V3, which must be V4. So right away, we know that voltage. And then to get the charges, we simply use that Q is CV. So Q3, VC1, VBAT, and Q4 would be C2, VBAT. And since we know the capacitors and the voltage of the battery, we can get those two charges. Now, Q3 plus Q4 will not necessarily equal Q1 plus Q2. Okay, so we don't write that there. Okay, now another variation for this situation is what if we connect them negative to positive? So the only difference there is if we start out with this one being positive at the top, whereas this one is negative at the top, and then we connect these guys, and no, we won't have a battery this time. Now, it depends which capacitor is bigger, which has more charge on it. Well, of course, the voltage and the charge are related to the capacitance, but whichever has more charge will negate. So let's assume that this Q1 and Q2, let's assume Q1 is bigger than Q2. So what will happen is this will become, remember these are in parallel, so they have to have the same potential top plate and bottom plate. But now this total charge, this will have Q3, this will have Q4. It'll be the difference of Q1 and Q2 because it's plus to minus. So Q total, charge is conserved, there's no battery, will be Q1 minus Q2. And that will be then the sum of Q3 and Q4. So it will appear as though you've actually lost charge, which is what happens because some of the positive charge on this Q1 will negate or cancel out what's on Q2, and what's left over will then be distributed between Q3 and Q4. Okay, so I think that pretty well covers all the scenarios for those kinds of problems.